Good evening, sports fans. Tonight we have a problem where we're actually trying to count the number of integer solutions. Now, since this is equal to 5, the ceiling function is equal to 5, you can anticipate x has to be a natural number, has to be positive. There's no way it could be negative, right? So this sometimes is called z plus, I think. So that's just kind of a conclusion. I could have put in instructions, how many natural number solutions do you have? But that's something that can be deduced just from the nature of the problem appearance. Okay, now this object here, folks, these square brackets mean ceiling. Here's a definition of what we mean by ceiling of a real number. And I use a question mark here just because x seems to get overloaded and does cause some confusion sometimes. So question mark can be any expression. It can be a number. So let's just do a concrete example here and see what we mean by ceiling. Let's do the ceiling. A lot of you have seen the floor function done on Michael Penn's channel quite a bit. The ceiling function is very similar. Let's say, let's do 12 points, whatever, 6. Okay, that reached 12.6, folks. Now the ceiling of that, and just the ceiling is very descriptive, that's going to be equal to 13 because 12.6 is between 12 and 13. So I'll put 12.6 here again. Now, you don't, just to do numerical examples, you hardly even need to write down the definition of what ceiling is. But it turns out it's useful to have something that's kind of formal for the definition. Okay. So there you go. That's an example. Again, I use question mark intentionally. Some people aren't bothered by putting an x here, but there's an x in this expression. And this question mark it's just any object, whether it's numerical, where it's an algebraic expression, whatever, could be your question mark, okay? Okay, so let's move along. Now, we're going to apply the definition of the ceiling function to the input argument here. So in other words, this part this entire piece here would be just like the question mark that you see down here in the ceiling definition, right? Now we know that we need the ceiling to be equal to 5, right? So that means we got to trap this between 4 and 5, just like I've written in this very first statement. Now I won't say too much here. We don't even have to know what the common denominator is. We multiply through by 6 times 23. 6 and 23 are both prime numbers. We don't know that 6 times 23 has to be 138. You can just multiply through by that. You get a lot of nice cancellation. You get this equivalent inequality right here. If you carry out the multiplication and subtract 23, you get down to here, okay? Now, what we've done actually, remember, what are we looking for? We're looking for how many integer solutions, right? We're looking for how many integer solutions, okay? But what we've done, we found something even stronger. The solution interval, if you guys are familiar with interval notation, you can write the solution interval. This is any real number in this interval would satisfy the conditions here. 529 divided by 42. All right, again, folks, this is interval notation, comma, and then we're going to have bracket. Because y'all, the ceiling of a number is the number. That's why you have the less than or equal to in the definition. So we have 667 divided by 42. All right. And y'all, this would be what they would call let me put 42 right there also. That's 42 and this 42. Okay. Y'all, this is the solution interval, which again is strong. Any number in this interval would satisfy the original problem. But remember, it says how many integer solutions. Okay, well, you can do a little bit of arithmetic. I won't go through all the treacherous arithmetic, but it turns out 13, 14, and 15 are members. If you've seen this membership, epsilon members, they're proud integer members of this interval, all right? Now, the only one I could do in my head would be, you may notice that 15, 42, times 15. Let's see, we can do that one in our head, right? 42 times 15 is what? 630, right? So notice the 630 that we get here is less than 667. But that would be the largest integer. If you got to 16, 42 times 16 is a bigger number than 667. And you can do similar types of arithmetic statements to get that 13 is the first integer, 14 is the second integer, and 15 is the third integer. So this is the solution, folks. Now I want to repeat, well, actually, there's actually three. The answer would be three, right? We've got to answer my own question, right? So there's three solutions. Is what was asked. Okay. So let's come up here. How many integer solutions? The answer is 3. All right, folks, that's all. Again, a fairly straightforward problem. Nothing fancy happened on this problem other than we directly appealed to the definition of the ceiling function. We didn't have to do anything clever. It would just kind of plow straight through in a straightforward fashion. So again, this is the solution interval. There's 3 integers in this solution interval. Above and below, this is the lower bound. 13 is a little bit bigger than this number. 15 is a little less than this number. So these are the only integers that satisfy the condition. So again, the answer is 3. Good night.